Smith here with one more flipped classroom math video for your enjoyment. 3 tips. First, you can speed up or slow down the playback if that helps you follow along. Second, you can pause anytime to catch up with your notes or think a little harder. Lastly, you could turn on the captions, which will show you my words on the screen below. Today's topic, angles of elevation and depression. And so first off, we're just going to talk about what these things are. The actual math is not super hard, and we're going to use trigonometry to solve these 2 problems. But first, let's just talk about definitions, okay? So this first picture here, I've got a cliff on the ocean with a boat. This is my little cartoon. I hope it works for you. And this is the angle of depression. So if there's somebody standing on the top of the cliff looking down at the boat, the angle of depression is the angle from the horizontal down. So they might be looking 30 degrees down, they might be looking 20 degrees down, something like that. So angle of depression, think about depressed, you're down, is looking down. Okay? So that's the angle of depression. Now check this out. An angle of elevation is up from the horizontal. So in this case, we might be standing on the ground looking at the top of a skyscraper, and we're looking up. Some angle is going up. That's the angle of elevation. And the thing about that is, if you feel elevated, you're up. Okay, let's use these concepts and do 2 SOHCAHTOA trigonometry problems. Okay, so here's a typical problem you might get with an angle of depression. A person standing at the cliff is looking out in the ocean at a ship. The angle of depression for their line of sight is 30 degrees. The cliff is 66 meters high. How far is the ship from the cliff base? Now, if you're feeling aggressive, pause the video right now and see if you can solve this one. Okay, now you might have bumped into something a little difficult. This 30 degrees is not inside this triangle. So what we have to recognize is that the cliff is vertical, so it's going to make a 90-degree angle with the horizontal. So what we need is this angle here. The 30 is not inside our triangle. But what we can do is we know if this is horizontal and the cliff is vertical, this plus that has to be 90. So that leaves 60 for here. So now I'm all set to use SOHCAHTOA trigonometry to find the distance from the ship to the base of the cliff. I'm going to mark that X. We know this angle and we know this side. So if you haven't solved it already, pause the video and see if you can find X. Okay, let's see how you did. If I'm at this angle, I'm looking at my opposite and I have my adjacent. So in SOHCAHTOA, that's tangent. Tangent is opposite over adjacent. So what we're going to write is tan 60 equals opposite x over 66 meters. Now when the variable's up high, we multiply these other 2 quantities. So now we get 66 times tan 60 equals x. I'm going to pull out my calculator and get that done. Okay, so I crunched my numbers and I got 114.32 meters. Now let's take a look at our picture. Does that make sense? This is an important step because sometimes if your calculation goes astray, you might not, if you don't check it against the problem, then you might get it wrong and not know that. So if this is 66 meters high, kind of makes sense that this would be 114 meters. Okay? It seems about right for our drawing. So that's my reality check and I feel good about that. Okay, now let's take a look at this other one, angle of elevation problem. Here we have our skyscraper, person on the ground here, angle of elevation is 71 degrees. They're asking us how tall is the skyscraper. So pause the video and see if you can crunch those numbers. Okay, let's see how you did. Now this one is going to be another tangent problem. The skyscraper is x high. I'm just marking that on the diagram. So if that's x, I know this angle, I know this side, and I want this opposite side. So it's very similar to this problem. So what I'm going to do is do tan 71 equals opposite x over 760 meters. Variables up high, we multiply these two quantities. So I have 760 times tan 71 equals x. Let's find out what that is. Okay, so what I got was 2207.2 meters. Now let's do a reality check. If this is 760 meters to the base, then could this be 2,207 meters? Yeah, it seems about right. It's in the right ballpark. Okay, let's do an IB style word problem that uses these ideas. Here's the problem. A ramp is constructed to give wheelchair access to a house. Can't go upstairs in a wheelchair. The ramp is the house is 1.35 meters above the ground. And here's a condition that's important. The ramp cannot make an angle of more than 8 degrees. We don't want a super steep ramp for our wheelchair. Okay, so we got 3 things we need to do. First, draw a diagram. For any geometry problem that is given to you in words, make a diagram. When I grade tests, that diagram is worth points. It's also going to ensure that you get the answer correct. So step 1 is to make a diagram. Step 2, how long is the ramp? Find the length of the ramp. And then the third thing is going to be find the distance of the ramp from the house. So if you want to pause the video right now and try to do all those, awesome, do that. Otherwise, just try to draw a good diagram. Okay, let's see how you did. I'm going to make my ground, and here's my house. Some house like that, and I have a ramp that's going up. There's my right triangle. This is maybe where the door is. So we're going up to that. We know that that point is 1.35 meters high. And we know that this angle has to be 8 degrees. Right there. Okay? So that's everything that we know in this problem. That diagram is going to prove essential for answering questions B and C. So why don't you go ahead and try B. See if you can find the length of the ramp. Okay, let's see how you did. First thing, mark your variable on your diagram. So there's my variable, x. Now I'm going to look at my SOHCAHTOA trigonometry, and I'm going to realize that it's sine. Because I have sine of 8 degrees is opposite, which I know, over hypotenuse, which I don't. So I can write this equation. Sine 8 degrees equals 1.35 over x. Now, when the variable's down low, you switch, you know. So this is going to give us x equals 1.35 over sine 8. Now let's get the calculator out and find out what that is. Okay, I punched it out, and I got 9.7 meters for the length of the ramp. Now does that make sense? Yeah, looks pretty good. If this is 1.35, this could be 9. That's cool, I like that. Now, when you find something out about a situation with a diagram, and you're going to go on and do other problems, it's a good idea to mark your new value on here. So I'm going to go equals 9.7. Okay, now, if you've been working up to this point and haven't done C, pause the video and see if you can do that. Find the distance of the ramp from the house. Your first question is, what distance is that on my diagram? Okay, let's see how you did. I'm going to use y, and the distance of the ramp from the house is going to be this distance along the ground, and that's going to be y. And so now, I need to write a trig equation using my 8 to find my y. Now in this case, there's 2 ways I can go. Pause the video and see if you can figure that out. Okay, I can use tangent, like we did with the last 2 problems, because tangent of 8 is 1.35 over y, but I can also use cosine, which is the one I'm going to use because we haven't used cosine yet in this lesson. Cosine 8 is adjacent over hypotenuse. So I can write cosine 8 degrees equals adjacent, which is y over hypotenuse, which is 9.7. The variable's up high, you multiply these 2 quantities. So I'm going to get 9.7 times cosine 8 equals y. Let's figure that out. Okay, I punched in my numbers. I did all my math, I got 9.61 for the distance of the ramp to the house. Now let's take a look. Does that make sense? In fact, it does. This is a pretty small angle, so that means the ramp is only going to be a little bit longer than the distance from here to here along the ground. And that's true. We got 9.7 for the ramp, 9.61 for the distance along the ground. Alright, now that you've watched the video, take a minute and jot down any remaining questions so you can bring them to our next class. Also remember, you can watch the video again. Maybe that will deepen your understanding. If you like the video, please click like and subscribe.